Okay, so you have here your first example. A man weighing 70 kilograms in an elevator moving upward with an acceleration of 2.5 meters per square second. Neglect the weight of the elevator. Number 1, calculate the tension developed in the cable. And then number 2, calculate the tension developed in the cable when the elevator is descending with the same acceleration. Okay, so you have here your elevator, which is carrying a man which weighs W, which is in W natin is your weight for the man is 70 kilograms. Okay, basically that is his mass. Okay, so no, let's denote this one as M since that one is your mass. Okay, so your M is equal to 70 kilograms. So your mass or the weight of the person is basically weight is equal to mass times acceleration due to gravity. So in this particular system here, wherein the elevator is moving upward at an acceleration of 2.5 meters per square seconds, okay, tension is developed at the cable which carries your elevator cart. Okay, let's denote that one as T. Now, based from what we have discussed in your kinetics, okay, your summation of forces is equal to mass times acceleration. Okay, so in this particular case, summation of forces is equal to mass times acceleration. Let's take positive upward. Okay, so in the upward direction, taking the whole system as your free body. Okay, on the upward direction, you have here your tension and your acceleration is moving upward. Okay, those are the forces or those are the vectors which would be pointing in the upward direction. On the downward direction, you have here your W. Okay, so first is summation of forces. So for the forces which are pointed upward, you have here T. Okay, and then nothing more. And then for the forces which are pointed downward, like for example W, you have here minus W, since that is against your sign convention. That would be equal to mass times acceleration. Acceleration here is positive since you have here a positive or the direction of A to be pointed upward. Okay, so calculating for or substituting values, T here would be what? T minus W, that is the weight of the man, that is 70 times 9.81 meters per second square is equal to mass, that is 70 times you have 2.5 meters per square second. Okay, so transposing to the other side of the equation, T or the tension developed on your cable is 70 times 2.5 plus 9.81, or basically that is T equal to 861.7 newtons. Okay? Next, number 2, calculate the tension on the cable when the elevator is descending. So instead of acceleration equal to 2.5 on that direction, it would be acceleration equal to 2.5 on this particular direction. Okay? So taking summation forces is equal to mass times acceleration, taking positive again upwards. Okay? On the upward direction, you have here T. And then, downward, you have minus W is equal to mass times acceleration. In this case, you have here a negative acceleration. Okay, so you would have here now tension T minus 7T times 9.81 is equal to mass is 70 times negative 2.5. Okay, so you have here tension T now is equal to, transpose to the other side of the equation, 70 times 9.81 minus 2.5. That would give you a tension which is equivalent to 511.7 newtons. So in this case, in this particular case, let's try to observe when the cable is or when the cart is being pulled upward, you have a higher tensile force developed on the cable compared to that when the cart is moving downward. Okay, so that is one observation for this particular case.